Okay, hello everyone, and thanks a lot for joining this webinar organized by the CIDE, the Italian Econometric Association. I'm Emanuele Bacchiocchi, and today I will play the role of a moderator in this webinar. It's a great pleasure for me to introduce Luca Fanelli, the speaker of this webinar that is not simply a colleague, is also a dear friend. Luca is professor of econometrics at the University of Bologna. His research mainly focuses on time series econometrics and on macro econometrics in general. He has theoretical and empirical contributions in practically all top journals in our discipline, like Journal of Econometrics, Journal of Applied Econometrics, Econometric Theory, JBAS, and so on. Today, Luca is going to present a paper on identification for proxy-SVARs with weak proxies. Before starting, I have a couple of recommendations. The first one is for Luca. As you know, you have more or less 1 hour for presenting your paper. The second one is for the audience. If you have any question, you can type. First of all, don't hesitate to write questions. First of all, type your question on the chat, and then I will pass all the questions to Luca throughout the presentation. Okay, Luca, the floor is yours, and good seminar.
Okay, thank you very much, Emanuele. Thank you for the nice presentation, and good afternoon from a red zone, okay? First of all, I want to thank the Italian Econometrics Association for inviting me to give this webinar. I have many colleagues and friends in the CIDE, and they know that I'm very attached to the CIDE, so it's great pleasure and honor for me today presenting my work. So my talk today will be based on a paper which kind of summarized the research activity I have carried out in the last, say, years with Giuseppe and Giovanni on the topic of proxy-SVARs and the use of bootstrap methods in these models. Let me start with the motivation. So proxy-SVARs, or if you prefer, structural VR models with instrumental variables, are probably currently, along with local projection, are the most popular tools used in empirical macroeconomics in order to track, to recover the dynamic causal effects of macroeconomic shocks. And the fathers of this approach are Mertens and Raven and Stock and Watson in independent contribution. These models solve a partial identification problem. Imagine that we have a VR model, and we know that embedded in VR innovation, there are potentially many structural shocks. But we know that recovering, say, many structural shocks by imposing restriction can be challenging, because in many cases, not all restriction can be uncontroversial. So the idea is to focus just on a single target shock or on a subset of structural shocks, and to use variable external to the VR model, which are correlated with the target structural shock and are uncorrelated with the rest of the system. So the idea is very similar to regression model with instrumental variable. The main difference is that in IV regression, we instrument an observed endogenous regressor. In this case, we are instrumenting a latent structural shock. And one of the main challenges we face in this setup is that the external variables, or proxies or instrument, I will use these three terms as synonymous in my presentation, can be poorly correlated with the target structural shock. By poor correlation, I mean a situation in which we can model the covariance between the instrument and the latent structural shock by local to zero condition a la Steiger and Stock. And we know that in cases like this, the inference in proxy-SVAR is no longer standard, and we have to move to robustify the inference, okay? To my knowledge, there are two recent papers which address the problem of making inference, robust inference in proxy-SVAR with weak proxies. both papers are forthcoming on the Journal of Econometrics. So the frequentist solution has been developed by Montiello, Lea, Stock, and Watson, and their recommendation is more or less to extend the logic of Anderson-Rubin test to the case of proxies-SVARs. So the idea is that we can build asymptotic valid identification robust confidence sets for the input response function of interest by test inversion. Okay. In the Bayesian framework, there are many contributions on proxy-SVAR. I have reported here that this by Giacomini, Kitagawa, and Red, because they explicitly focus on the case of weak proxies. So weak proxies is not only a concern, an issue in the frequentist setup, but also in the Bayesian one. But as is typical of the Bayesian approach, they combine, say, external variable with set identification. So in this paper, we are concerned with, we present a frequentist approach, and I will discuss basically point identification. So, and we'll try to present kind of alternative to Montiello, Lea, Stock, and Watson. So let me focus a little bit more on their contribution. Basically, their approach is particularly suited, is designed for the case of a single target shock. That is the case in which epsilon 1t is a scalar, is a scalar, so k is equal to 1, okay? In this case, a unit effect normalization typically is sufficient to build an identification robust confidence set. By unit effect normalization, I mean something like, say, imagine that I impose that the response of tax revenues to the identified tax shock is equal to 1 or to something. And by using that restriction, I can go to the algebra of test inversion. I can build an identification robust confidence set. However, the situation becomes more problematic in the multiple target shock case. That is when epsilon 1t is a k-1 vector with k larger than 1. Imagine, for instance, that I want to identify jointly the tax shock and the fiscal spending shock because I want to recover fiscal multiplier, okay? So in this case, unit effect normalization are no longer sufficient to invert the test. We need a number of restrictions typically larger than the number of restrictions that we need to impose under strong proxy. And please let me recall that when k is larger than 1, we need additional restriction in the proxy-SVAR other than the proxy, okay? So placing many restrictions, of course, is against the logic of proxy-SVAR, because in proxy-SVAR we want to use external variable and we would like to keep the additional restriction to a minimum. Otherwise, we come back to traditional structural VR model. And also in the multiple target shock, typically we have to postulate some parameter for values for many parameters, not just one. And inverting the test can be complicated. We have to resort to numerical methods, and the inference becomes conservative. So we want to address this problem. And now I'll show you how we attack the problem. So the idea is the following. In the standard approach, you will understand later on, while you will understand immediately why I call it a direct approach. In the standard approach, what we do, we focus our attention on the target structural shock, okay? And we focus on variables ZT, which are correlated with the target structural shock up to measurement error, okay? Now imagine that we don't know whether our proxy are strong or weak, okay? We don't have an idea about the strength of the proxy. And I will provide a formal definition of strong and weak proxy later on. But for the moment, please believe me that the strength of the proxy is related to the rank condition on the phi matrix I have here. And so when I don't know, when I'm not sure about the strength of the proxy, Montiello, Lea, Stock, and Watson recommendation is to apply identification robust method, okay? But now imagine that I have a vector VT of external variables, which are correlated with a subset, epsilon 2 tilde, of the auxiliary shock of the system. The auxiliary shocks are the ones we want to get rid in a proxy-SVAR approach. But imagine that we have a relationship, a relationship like this. So we have a vector with T, which is, say, related to a subset of auxiliary shocks up to measurement error. And imagine that we know that our proxy VT are strong, okay? So the idea of the present paper is that we can use strong proxies VT for the auxiliary shock in order to recover the dynamic causal effects implied by the target shocks, epsilon 1t. And this is particularly convenient because, I mean, when we're not sure about, say, the proxy, the strength of the proxy ZT, we can circumvent the use of non-standard method of inference. And this is particularly, say, nice, particularly convenient in the multiple shock case, when case is larger than 1. So in this paper, we provide 3 contributions. Then, Emanuele, I will make a first break, okay? So we provide 3 contributions. First, we define an identification strategy that I call indirect approach, where we recover the dynamic causal effects of the target shocks by instrumenting the auxiliary shocks of the system. And to do that, we exploit the relationship between the B form and the A form representation of a proxy-SVAR model. We design a novel minimum distance estimation method. We derive necessary sufficient run condition in this case, and we show that, okay, when we are using strong proxies for the auxiliary shock, inference is standard. So we can circumvent, say, the use of non-standard methods of inference. Of course, it is crucial in this approach having strong proxies for the auxiliary shock. That's why in our second contribution, we present a novel test for instrument relevance, which is based on bootstrap resampling. In particular, we're going to use the bootstrap algorithm will be the moving block bootstrap. And I will say something more on that later on. And the special feature of our test is that it implies no pretesting issue. What do I mean by that? Imagine that before running our identification strategy, we use our, say, bootstrap test as a pre-test for testing, say, whether the variable VT are strong or weak for the auxiliary shock. Well, by doing that, we are not affecting in repeated sample the inference in our strategy. So this is quite important relative to the use of first stage F statistic, where we know that, I mean, we are pre-testing the usual pre-testing issues. And then on the empirical side, what we'll do in this paper is to we apply our methodology to estimate the size and associate uncertainty of US fiscal multipliers from a fiscal proxy-SVAR. Of course, we are aware that there are many important contributions of proxy-SVARs in the fiscal framework, but from our point of view, this is kind of ideal situation because we have a multiple shock setup, k is equal to 2. We need to identify simultaneously the tax shock and the fiscal spending shock. And it will be not, I mean, it will be useful to compare how our strategy compares relative to the direct approach. The direct approach is the one in which we use narrative fiscal proxies, for instance, for the fiscal shock. And this is a setup in which we might be concerned about the strength of the proxy. And let me give you just the idea, then I stop. On the right-hand side, I have reported the narrative proxy used by Mertens and Raman in a fundamental contribution, the journal Monetary Economics. They use this variable to instrument the tax shock. And they estimate, by using this variable, a tax shock of larger than 3 point something, okay? Which means that $1 cut of taxes gives back to the economy, say, $3 after 3 or 4 quarters. Now, Mertens and Raman, they elaborate this variable from previous work by Romer and Romer. Romer and Romer make a wonderful job in recording by reading official documents from the Congress Budget Office or presidential speech. They identify exogenous variations in tax policy. And you see that you find, say, many, the spikes you find in this time series are very informative about tax policy. But from a time series point of view, we recognize that that variable is, say, a 0 sensor at time series, and also the zeros are important in this setup. So if the spikes are very important, give information about, say, the strength of the proxy, the zeros we have in this time series tend to offset. So we might be concerned about, say, the strength of a variable like that. And so our approach allows us to circumvent a problem like this. So, Emanuele, before going to the outline, if you have a question, I'm ready.
Yeah, Luca, that's a question from the audience by Alessandro Casini. And to be honest, I had a very similar question. The question is, do you need to have proxies for all the auxiliary shocks in what you call epsilon tilde, or only for a subset of it?
Only for a subset, S. Of course, it depends. Okay, if S is equal to n minus k, of course, I have proxy for all the auxiliary shocks, but potentially I can have a proxy also for a subset, but then it means that I have to put some additional restriction in the proxy-SVAR, okay? But in order to get the point, you have to wait a little bit until I come to the identification conditions, okay? So
okay.
the answer is yes. S can be strictly less than n minus k. Okay.
Okay, Luca. Sorry, it's a matter of notation. What's the difference between what you call epsilon 2 and epsilon tilde 2?
This is a subset of it's just a subset. Okay.
Okay.
It's a subset.
Right. Okay.
Okay.
Great.
Okay, this is the outline of my presentation. I will discuss the identification strategy, and probably I will spend most of my time to that. So I will discuss with you the relationship between the B form and the A form of a proxy-SVAR. Then I will move to our indirect minimum distance estimation approach. So I will discuss necessary sufficient run condition for identification. And in order not to bother you too much, I would like also to discuss some examples, but not only example taken from the fiscal framework, okay? In the second part, if I have time, I would like also to discuss with you the novel bootstrap diagnostic test for instrument relevance. I will discuss the sketch of the idea, part of the mechanics of the test. You have the slides, so after the end of the slide, you will find some extra material where you can find the mechanics, and we can discuss that whenever you want. I will provide you with the operational form of the test, which is very simple to apply, straightforward. I will present some Monte Carlo results, and finally, I will come back on the problem of screening, deciding whether we are dealing with a strong or weak proxies based on our bootstrap test. Finally, the empirical analysis at the end of the day will be a simple table where I compare fiscal multiplier estimated by our approach and the direct approach, the one in which we use, say, fiscal instrument to identify fiscal multiplier. And then I have some concluding remarks, okay? So I start with the identification strategy. Let me start with the B form of a proxy-SVAR model. So I start from a structural VR model. I have just one leg to simplify the things. UT is the vector of VR innovations. Epsilon T is the vector of structural shock. I normalize the variance just for simplicity, but I could relax this condition. And this is the mapping from the structural shock to VAR innovations. And when we use the B model in a structural VR model, we know that we identify the shock by characterizing their impact on the variable UT. You say, I call the variable UT just because UT are the variable ones I filter out for the dynamics, okay? So in the proxy-SVAR, the focus is only on the target, on the first K target structural shock of the system. Let me say that ordering is not important in this setup. I put the target shock first just for simplicity, to simplify notation, but ordering is not important. So when the focus is only on the target shocks, we have a relationship like this, where we only focus on the target shock, and we want to get rid of the auxiliary shocks, okay? And to do that, we are looking for external variables which are correlated with the target shocks and are uncorrelated, orthogonal to the auxiliary shocks. And the input response function we are interested in this setup only depends on the dynamics and on B1, okay? So it's important to remark that in this setup, in the B form, the auxiliary shocks have no role in the identification, okay? Now, we know that if B can be inverted, we also have the A form representation of a structural VR model. And if we think about the A form, when we estimate a structural VR model in A form, we recover the structural shock by modeling, say, the structural relationship between the variables. So we have in mind kind of the space row of the matrix A. But also in this case, of course, we can disentangle, we are in a partial identification setup, so I can disentangle the system into two blocks, the blocks associated with the auxiliary shocks, K by 1, and then I have the rest of the system, okay? Now, let me focus on this block, okay? This system of structural equations, and it's possible to prove that the link between this B1 matrix and the following A1 matrix is given by this relationship here. Very simple. B1 is given by sigma u. Sigma u is the covariance matrix of the var innovation times A1. And this is important because recall that we are interested in the following impulse response functions. And by using this mapping, we can shift the inference from B1. And recall that in B1, the auxiliary shock have no role, are not important. We can shift the inference from B1 to A1, given that we can pick out sigma u from the data in a very simple way under very standard regularity conditions. So our point is that once we move our attention on A1, the auxiliary shocks have a role in the identification of A1. And of course, they have a role in recovering the structural target shocks. And I want to show you that with a couple of examples. Can I go on, Emanuele, or are there questions?
Yes, you can go on.
Okay. So example number 1, I take this example from the macro and financial uncertainty literature. Imagine that I have a small scale, a 3-equation VR model, including, say, a measure of financial uncertainty, macro uncertainty, and the real economic activity, okay? For instance, I could take the growth rate of industrial production growth, okay? And a small system like that has been used in other contribution, including myself and Giovanni. And imagine that the objective now is to identify the impact of the financial and macro uncertainty shock on real economic activity, okay? So in this case, the target shocks are given by the financial uncertainty shock and the macro uncertainty shock. So K is equal to 2, okay? And this is the B form of the model, okay? Since K is larger than 1, okay, we need at least 2 instruments, 2 proxy in order for the 2 shocks, but we also need to impose an additional restriction, okay? You can take the restriction on the beta coefficient here, or you can place a restriction on the phi matrix or relevance parameter here, okay? But imagine that I consider difficult, challenging finding simultaneously 2 proxies, 1 proxy for the financial uncertainty shock, 1 proxy for the macroeconomic uncertainty shock. So what I can do, I could think differently. I could refer to the A form representation of the structural VR model. So I have 2 structural equations like this, okay? I have 6 parameters in A11 and A12, but also in this case, I have to place at least 1 restriction other than the proxy, okay? So I have to kill 1 coefficient in these matrices. And let me say, this is very important. I'm not constrained in my approach to kill coefficient only in A11. I can also place restriction on the other side. And you will understand that is an important difference relative to IV. Okay, but let me come back to the point. So with this representation, we have the financial uncertainty shock, the macro uncertainty shock on the right-hand side. And I could do the following point. I mean, imagine that I have a proxy VT for the real economic activity shock. So I have a relationship like this. And if I have a strong proxy, I could do the following exercise. Take the variance of this system, okay? And you get the following set of moment conditions. You get 3 moment conditions, okay? Then you interact your instrument, your proxy for the auxiliary shock with the VR innovation, and you get this set of 2 additional moment conditions. So you have 5 moment conditions to estimate 5 parameters alpha in this matrix by using a minimum distance estimation approach that I will describe later. Okay, so we are reverting probably, we are reverting the problem. Another example, this is a very famous Killian oil supply shock. Killian has a very, say, famous paper, 2009, on the American Economic Review, where he shows that, imagine that you take, say, a measure of a percentage change in global crude oil production, global real economic activity, and real oil prices with the following ordering. And it shows that going Cholesky with the following ordering, you can recover the oil supply shock, an aggregate demand shock, and the oil-specific demand shock, okay? There is a huge literature on the identification of the oil shock. I don't want to enter that literature, but imagine that we are concerned about using Cholesky, okay? And for instance, Montiel, Stock, and Watson say, okay, I want to identify the oil supply shock by a proxy-SVAR approach, okay? So in this case, the target shock is epsilon 1t, which corresponds to the supply shock. K is equal to 1. We have a single target shock, and the B form would be something like that. And for instance, Montiel, Stock, and Watson say there is a paper by Killian, 2008 Restat, where he provides, say, an exogenous variable, an exogenous proxy for the oil supply shock. So we could use a relationship like this, okay? But Montiel, Stock, and Watson show that in this case, the robust first stage F statistics is 9.4, so less than the threshold 10. And so they say, okay, we have to apply identity method because we are not sure that the proxy is strong. How can we circumvent the problem? Imagine that if we take the A form, in this case, is given by the following structural equation, okay? And in this case, I need, in this case, the auxiliary shocks are, say, the aggregate demand shock and the oil-specific demand shock. So imagine that I can take at least 2 proxy for this variable. Unfortunately, we don't have yet the empirical result. We are working on that, but our idea is taking, for instance, Francesco and the co-author Vespignani. Francesco has this index of global real economic activity, which is correlated with Killian's index of real economic activity. And we are thinking about using, for instance, a future on the Brent or WTI as a proxy for the oil-specific demand shock. So we can reformulate the problem like this. You take the variance of this guy, of this equation, and you get 1 moment condition from here. You interact our proxy for the auxiliary shock with the VR innovation, and we get 2 additional moment conditions. So at the end of the day, we have 3 moment conditions, and we pick up from the data alpha 1,1, alpha 1,2, and alpha 1,3. So if there are questions, I can take questions. Otherwise, now I formalize our indirect minimum distance estimation approach.
No question from the audience.
Okay, so we have the following 4 assumptions. Assumption 1 is a rater standard correct specification assumption, and I take stationary variables, okay? Assumption 2, we take var innovation as alpha mixing, so we can admit a weak form of dependence, so we can, our VR model can feature Garch type components. Assumption 3 is rater standard A is the inverse of B, which means that the row rank of A1 prime is the same as the column rank of B1, okay? And assumption 4 is a crucial one in our setup. We are assuming that we have a vector VT of proxy for a subset epsilon 2t tilde, okay, of the auxiliary shock, okay, up to measurement error. Assumption 4 makes no claim about the strength of the proxy. Our definition of strong and weak proxy is as follows. We define VT a strong proxy for epsilon 2 tilde if in a neighborhood of the true parameter value lambda, we have that the rank of lambda is full column rank regardless of the sample size, okay? And we define that VT is weak for the auxiliary shock if we locally, we can decompose the lambda matrix into lambda1, where lambda1 has reducer rank, okay? So, and plus a local to 0 condition. So in finite sample, we have the lambda matrix is near rank failure. And when capital T, when the sample goes to infinity, we have reducer rank. That is our definition of weak proxy, okay? And recall that our objective is to estimate the following impulse response functions, okay? By using, and we can basically map our inference from B1 into A1 by using this relationship. So from the A form, we have the following A form representation on the proxy-SVAR model. By taking the variance of this guy, we get the following set of moment conditions, okay? And by interacting our proxy VT with the VR innovation, we get this additional set of moment conditions. Unfortunately, when k is larger than 1, these moment conditions are not sufficient alone to recover the elements in A1. So we need a number, 1/2 k minus 1 additional restriction on the parameters, okay? And we can model this restriction in standard explicit form like this. So alpha is the vector of 3 parameters that enter A1. Capital SA1 is the selection matrix, and small sa1 is a vector which allows to manage also non-homogeneous restrictions, okay? So we can, given this moment condition and given this restriction, we can summarize all these conditions in a distant function. We take the vec of these quantities, and this function is equal to 0 when evaluated at the true parameter value. And we know that the reducer form parameters sigma u and sigma uv, which are the covariance parameters of the VR model, and the sigma uv is just the covariance between var innovations and the proxy. We, under the assumption I provided before, we can estimate this guy. We have a consistent and asymptotically Gaussian estimator of sigma. Just to see that this is the VR model, just append the proxy for the auxiliary shock to the system. You get an enlarged, say, vector of innovations, UT and VT, and the variance covariance matrix of this innovation includes, say, sigma U and sigma UV, and we know how to estimate these guys. So it is natural thinking about, say, a minimum distance estimation approach, because we have a consistent estimator of this guy, and we can estimate alpha by a Rater standard minimum distance estimation problem, okay? And before showing the properties, okay, what about, what are the necessary sufficient condition for identification? We can prove that under the assumption 1 and 4, under the 4 assumption I showed you before, the minimum distance objective function has a unique minimum in a neighborhood of the true parameter value, if and only if the following rank condition is valid. A is just the dimension of alpha, okay? And this dk plus is simply the generalized inverse of the duplication matrix, okay? Only necessary condition for identification is the condition I mentioned several times before. And you can revisit this condition as a condition that, say, the dimension of alpha must be less than the number of moment conditions. So this condition says that S is the number of proxies for the auxiliary shock, plays also a role in the identification. And we can prove that if this condition is valid, of course, one implication is that the proxy we are used for the auxiliary shock must be strong. That is, in other words, having strong proxies for the auxiliary shock is a necessary condition for this rank condition to hold. It's not sufficient because I could place restriction in the wrong place in the proxy-SVAR, okay? And are there questions, Emanuele? I can give you.
Not directly from the audience. I have a couple of curiosities. If
Yes.
you can go back, Luca,
yeah.
One more slide.
This one?
Sorry, one more. Yeah, right. So in the expression for the augmented VAR model that you have there, in the dynamics, you allow just pi1, capital pi1. that one.
Yes,
and you
yes.
impose zeros. Imposing zeros like that, is it important in terms of your conditions on identification and conditions for the estimator to be consistent, or it's just a matter of simplicity?
No, just matter of simplicity. Let me say that I'm considering here a setup in which VT, the proxy for the auxiliary shock, are already in innovation form, but I could have a more complex model for the auxiliary variable. So I can have, say, a variable VT, which is, for instance, which depends on the legs of Y and depends on itself. And of course, I have the innovation term I have here is something which should have the same properties as UT. Okay, now I'm simplifying just to simplify the setup. Okay, but the important thing is that you can estimate the covariance parameters in a standard way.
Okay, and the second one, Luca, is about the identification, the notion of identification you have in mind. I have the impression, given my experience in this topic, that now here you're dealing with local identification.
Yes, local, yes, right? Yes, I said a unique local minimum in the neighborhood of the true parameter value, yes. Okay,
okay. Thank you, Luca.
So, of course, our second proposition, given our assumption and given that the rank condition holds, which implies that our proxy for the auxiliary shock are strong, and if we are taking a condition like, say, the true parameter value is in the interior of the parameter space, we have that alpha is consistent and asymptotically Gaussian. And from this result, we can derive that also a plug-in estimator of B1 is consistent and asymptotically Gaussian, and we can derive also a standard normality result for the input response functions. Okay, so let me just qualify. Let me add some qualification about our contribution. You might say, okay, but the proxy, the Bayesian approach to proxy-SVAR is based on the A form. So what's new in that? The novelty, because if you look at the contribution by Caldara and Herbst, Arias, Rubio Ramirez, and Wagoner, Giacomini, Kitagawa, and Red, they are based on the A formulation of the proxy-SVAR model. But what they do, they proxy the target shock, not the auxiliary shocks. The only, to my knowledge, the only case, the only contribution in the literature where, say, non-fiscal proxies in the fiscal proxies, in the fiscal framework, the only case in which non-fiscal proxies are used to instrument non-fiscal shocks is this important paper by Caldara Camps. But they have a Bayesian penalty function approach, and our is a frequentist approach. We deal with point identification, and as you saw with the example I presented before, we don't need, our approach does not require that we have, say, a policy, fiscal policy reaction function of monetary policy. Our approach can be applied to any context, to any setup, provided we have strong proxies for the auxiliary shocks, okay? And when k is larger than 1, our minimum distance estimation approach is more general than IV, the instrumental variable approach provided by Mertens and Raven. Also Mertens and Raven, they instrument the target shocks, not the auxiliary shock, okay? And they need to impose a Cholesky structure to this matrix. They need to impose that A11 is Cholesky in order to apply instrumental variable. We don't need such a restriction. We only need that our necessary sufficient rank condition is satisfied in our setup, okay? Now I would like to show you some empirical results.
Sorry,
based
Luca,
on, yes.
Sorry to interrupt you, but you have to impose restrictions too, right? Not exactly like in the Cholesky style, but you have to impose the same number of restrictions. What you
you're right.
As k minus 1/2.
Absolutely,
okay, but in a different subset. In a different.
Yes, but let me be more precise about that. Imagine that this is the A form, okay? I want to give you an instrumental variable interpretation, okay? This is the A form, okay? Imagine that A11 is invertible. We don't need such restriction in our setup. But if A11 is invertible, you can rewrite the system like this, like a regression model, okay? And where psi is given by this expression. And since U2 is given by, say, depends on the shocks epsilon1 and epsilon2, and if you have a proxy VT, which is correlated with the auxiliary shock and orthogonal to the target shock, so you can use the proxy VT as an instrument here to estimate psi, okay? And from the say, residuals you get from this model, you can recover A11 only if you impose, say, a Cholesky structure. Otherwise, no way of separately identifying the element in A11 and A12. We can place a restriction wherever we want. We don't need a triangular structure on A11, provided the necessary sufficient run condition works. Okay, so we are a more flexible setup. Okay, let me provide you some empirical results. So we have a VR model, a fiscal VR model, including, say, a measure of tax per capita tax revenues, per capita fiscal spending, real GDP, and they have included a measure of real interest rate to account for, say, the stance of monetary policy. Okay, the fiscal multipliers we want to recover are defined. We have a definition of fiscal multiplier consistent with Blanchard-Perotti, Mertens-Raman, Caldara-Camps, okay, which is given basically, it is a rescaling of the dynamic response of GDP to the tax shock and the dynamic response of GDP to the fiscal spending shock, and there is some scaling factor by which we convert the impulse response into dollars, okay? Of course, Ramey would not be happy about this definition, but we stick to this kind of definition. And now, let me say, imagine that I want to follow the standard approach, the one in which I have, say, the target shocks are the tax shock and the fiscal spending shock. I want to use proxies for these two shocks, okay? So I have in mind a relationship like this, measurement error here, and by combining this proxy with VAR innovation, we get this is the relationship upon which estimation is based, okay? Now, imagine that I use the Mertens-Raman proxy variable as a proxy for the tax shock, and I use this also narrative variable used by Ramey. This is a narrative military spending narrative proxy. So this peak you find here in the 50s, it is the war in Korea, this huge peak, okay? And I use this guy as an instrument for the fiscal spending shock. And imagine that I estimate my model regardless of whether I have strong or weak proxy, okay? I pretend I have strong proxies, and the results are in the upper panel, okay? Forget for the moment about the vertical bar, the black vertical bar you have here. So the tax multiplier is the red line you find here, and the red area are 68% moving block bootstrap confidence intervals for the tax multiplier. You can see that the instantaneous tax multiplier is 1.8, quite large, and the peak multiplier after 3/4 is 2.5, almost 2.5, which is less than 3 provided by Mertens-Raman. But let me say that differently from Mertens-Raman, I am including in the system also a measure of the stance of monetary policy, okay? And but you can realize that 68 moving blocks bootstrap confidence interval suggests that I have very unprecisely estimated parameters, okay? Forget for the moment about the p-values you find here on the right, which is the p-value of our bootstrap-based test for the null of strong proxy, okay? And let me do the following, let me blow up the following graph here, the tax multiplier. And I have a picture like this. So the red area is the moving block bootstrap, okay? The dotted black lines are what I get if I apply the wild bootstrap, which is not in this VR model. We have VAR innovations which feature gauge type components. So there is a large debate in the literature on which is the right bootstrap method in proxy-SVAR, but at the end of the day, it seems that the moving blob bootstrap, if you have strong proxies, okay, should be the more appropriate one. Is consistent, and you can apply that also when you have IID shock or you have, say, alpha mixing conditions. So this explains probably why it's a possible explanation of why Mertens and Ramno find that a significant multiplier, say, larger than 3, because if you apply the moving blob, the wild bootstrap, you would be tempted to claim that we have a significant estimate. Okay, now let me go on. We imagine that I'm not satisfied about the following, say, confident band, moving blob bootstrap confident bands, too large, and I have the suspect that I'm using weak proxies. Okay, so I robustify the inference along the lines suggested by Montiello, Leastock, and Watson. I don't want to bother you too much with technical issue. Just let me say that the idea in their approach is the following. I can rewrite the moment condition, the relationship between, say, the covariance between VAR innovation and the proxy. And this relationship can be decomposed like this, okay? And the idea is phi metrics as a function of, say, of the sigmas. We can estimate the sigmas consistently from the data. And imagine that I put the following restriction. I put B11 equal to the identity. So I am imposing 4 restrictions in this model. If B11 is set to 1, I can recover. I can say that phi prime is a function of the reducer form parameter, and I can start the algebra of test inversion. And what I can do is, for instance, I can say that I can impose the null hypothesis that the response of GDP to the tax shock and the simultaneous response of GDP to the fiscal spending shock is equal to given postulated values of the responses. Okay, and by applying, I don't want to bother too much with the algebra. At the end of the day, we find, say, an Anderson-Rubin region. We find, say, the confidence set containing all possible values of the responses, such that our test does not reject. Okay, and from an empirical point of view, and of course, this is a simultaneous confidence set. We can use the projection method in order to have, say, a confidence set for the tax shock and an identification robust confidence set for the fiscal spending shock. And then you have these vertical bars you find here. So you can see that in this case, we are driven by theory in inverting the test. We know that the tax multiplier cannot be larger, is between 0 and cannot be larger from an economic point of view than 6. We know that the fiscal spending multiplier is between 0 and no larger than 3. So you can see from the following estimate that, say, the projected 68 confidence the projected 68 confidence interval is, yes, is more informative than the one I showed you before, but is still quite large. And the point estimate is just it's just the point within the identification set with larger p-value, the last rejected value. It is a Hodges-Lehmann point estimate, which is very close to what we get previously. Okay, and finally we apply our, say, approach. So in this case, we have to change completely. We have to instrument now. In this case, no longer the tax shocks and the fiscal spending shock, but our focus now is on the output shock and the monetary policy shock of the system. Okay, so in this case, we have to impose a single restriction, and we can impose the restriction either on A11 or A12. We don't need necessarily a triangular structure on A11. And imagine that our choice is the following. We use a measure of total factor productivity for the output shock, this is a famous Fernald measure, total factor productivity. And we take a measure from Barakian and Crown paper as an instrument for the monetary policy shock. So in this case, we don't have zero censored variables. And the results are in the lower panel you find here. So we have a dramatic, say, decline of the size of the tax multiplier, which is less than 1, the peak multiplier, 0.96, and the confidence interval, the 68 moving block bootstrap confidence interval, is considerably smaller than relative to the literature. If you're familiar with the literature, you know that the tax multiplier it's very controversial issue, and we get an estimate of 1.5 for the fiscal pending multiplier, with also quite precise 68% confidence band. So our recommendation would be, based on our estimation, we would recommend, say, implementing a fiscal spending policy. With the other approach, it would be exactly the opposite, okay? And now, how much time do I have, Manuele?
You have 10 minutes. Sorry, Luca.
Yeah.
That's a question from Stefano Fachin.
Okay.
Okay, Stefano says, inference is non-standard if you want to take into account dependence across periods. Non-standard means that in order to construct joint confidence bands, you need to bootstrap anyway. So Stefano says, why should we care for the result that inference is standard? So he refers to one of your previous slides. So this is a theoretical question.
You mean when I said the minimum distance approach is standard?
Yes, I think so.
Stefano, I mean in that case that I have, say, the distributional impulse response function for each given horizon H, okay? Given that you fix the horizon H, I have, say, an asymptotic normal distribution. But if you have in mind, say, a joint confidence set for the entire shape of the impulse response function, if I get the point correctly, I don't know if that is the point. We can also go for that. We can also go for that. But my point is that we don't need to robustify, we don't need to apply, say, identification robust methods, because we have a standard asymptotics, okay?
I have a question, Luca, that could be provocative in a sense. In looking at your results, it seems that the fact that you add one more variable, say the
real interest rate,
real interest rate, in a sense allows you to have more information, not simply from the VAR point of view, but also for identifying the shock of interest, if in a sense.
Yeah.
So it adds, let's say, flexibility where to put the restrictions, but also.
I did it just because I wanted to check to what extent, say, you know, when you're dealing with fiscal policy, you should also take into account, from my point of view, what is the stance on monetary policy. Because, for instance, the sample I'm using covers runs from 1950 until before the global financial crisis, until 2006. And there are several monetary policies. We have at least the great inflation period and the great moderation. So I wanted to simply to control for the stance of monetary policy. You know, for instance, we know from manual that the situation in which fiscal policy is the best situation for fiscal policy to work in when you are in a liquidity trap and you make a massive fiscal expansion, what is doing President Biden in the US, and you are concerned, the idea is that you can shift aggregate demand, so people now is concerned about increasing inflation. With this choice, I wanted simply to control for that. But if I consider a smaller system, if I drop the real interest rate from the system, I get very similar results. I get the fiscal multiplier, the tax multiplier I get from by using, say, the standard approach is very close to 3 point something, like in Mertens and Raven Journal Monetary Economics paper. So I added that it's not providing, I mean, I can revisit, taking your point, if I drop this guy here, okay, so I only need to instrument the output shock, I get even better results.
Okay, thank you. Thank you.
So I would like just to spend, if there are no other questions.
You have more or less 5 minutes, Luca.
Yes, just 5 minutes for discussing the main idea behind our bootstrap-based test, okay? Look at the p-value I reported here. So in the direct approach, this is the null hypothesis of our test is that the proxy is strong against the alternative of weak proxy. So you can see that in this approach, we strongly reject the null, and with the other approach, with the indirect approach, we strongly accept the null of strong proxies. Now, I want to give you just the intuition. Our test is, the main properties are the following. There are no pre-testing issues, so we can screening. You can use our test to decide whether your proxy is strong or not without affecting the inference in the second stage. This is an important point in the weak identification literature. The test is computationally straightforward. We have to compute a normality test. I will give you very quickly now the operational form. And the test is robust to alpha mixing, VAR innovations, and the proxy. So we are going to provide you an alternative to the robust first stage F statistic. And our test, I mean, works regardless of the number of shock you are considering. And the bootstrap algorithm we are considering is the moving block bootstrap by Jens and Lansford, which have been introduced in the VR literature by Brueggemann and co-authors, and Jens and Lansford, they extend this methodology to proxy-SVAR. Okay, I have to skip technical details. Let me give you that you can find in the slides, but let me give you just the operational form of it, the way it works, just a very simple a sketch of the idea. So our null hypothesis is that the proxy VT is strong for the auxiliary shock. And we consider an estimator of the proxy-SVAR parameter, which captures the strength of the proxy. So our estimator is a function of the element of the lambda matrix and the element of the, say, of the B2 tilde matrix, where B2 tilde is the one which captures, say, the impact of the instrumented auxiliary shock on the variable. I'm not interested in this quantity just in itself. I just want an estimator which capture the strength of the proxy. I consider the bootstrap counterpart of this estimator, and I investigate the asymptotic behavior of the studentized version of my estimator and the bootstrap counterpart under strong and weak proxy. So our crucial result is that in the presence of strong proxy, we have asymptotic normality and the bootstrap counterpart conditional convergence in conditional distribution also to the normal. So this result says that the moving block bootstrap is consistent under strong proxies. Under weak proxies, the situation is completely different because we prove that this gamma T statistic is non-Gaussian, okay, under weak proxy, and we prove by using, say, results of the econometrica paper by Giuseppe and Ilian, we can prove that the cumulative distribution function of the bootstrap counterpart is stochastic in the limit, so it cannot be normal. By using this, by elaborating on this important proposition, at the end of the day, we can say that our test works like this. Imagine that by the moving block bootstrap, you generate a number n, okay, capital N of bootstrap replications of this estimator. Capital N must be selected such that the ratio between n over capital T in large sample converges to zero. And we find by, say, making many simulations that in the structural VR, in proxy VR models, the rule say take n equal to the integer of the square root of t, it works very well. And then what you do, you simply apply a normality test to the sequence, to the replication, to the n replication of the bootstrap. If you reject normality, the proxies are weak. Otherwise, they are strong. I have some Monte Carlo results that show you that we have good size coverage also when in the presence of Garch type var innovations, and the test has a relatively good power. Okay, the final result is that we can use, and then I can finish here. Basically, we can prove that if you take any statistic from the proxy-SVAR model, it is asymptotically independent from our, say, bootstrap-based test, which means basically that's a large sample for t, and then that goes to infinity. Any test statistic taken from the proxy-SVAR is independent, is asymptotically independent from our bootstrap-based test. And this means that you can screen based on our test without affecting the inference. But Emanuele, I think we are.
Yeah, you have, if you want,
so
more or less 1 minute for concluding.
Yeah, just concluding, let me say that, just to say that because of this property, we use our bootstrap-based test as a part of the identification strategy. So at the end of the day, okay, I have just this table which compares fiscal multiplier estimated by different methods, but let me go to the conclusion. So we have been dealing with proxy structure of your model with multiple shocks, okay, and in the case of weak proxies, our contribution is that, okay, we are provided an identification strategy and a minimum distance estimation approach by discussing local identification condition. We have derived a novel bootstrap diagnostic test which can be used as a part of the strategy. We have provided some inference on US fiscal multiplier, but we were curious about comparing our results with other type of proxy structure of VR approach. The advantage of our approach is when K is larger than 1, the multiple target shock. And that should be clear from our fiscal framework example. Of course, there is one limit. You might consider a problem in which you don't have, say, strong proxies for the auxiliary shock. So in that case, if you have, say, weak proxies for the target shock, you have to stick to Montiello, Lea, Stock and Watson recommendation. So thank you very much for the discussion, for the questions.
Okay, Luca, that's a final. Thank you very much. First of all, really nice presentation. There's a final, or at least one question from Camilla Mastromarco, saying that asking whether your approach is is it simpler to find strong instruments?
Is it simpler to find strong? I mean, in the sense we have a test where the crucial fact of our procedure is that we have a test, our bootstrap, we can screen, we can look for strong proxies by screening, by using our bootstrap test without affecting the inference. Let me show you this graph, Camilla, very, very quickly. This is, I mean, this should be, we are considering the coverage of impulse response function. We are considering the impact of shock epsilon 1t on variable y3 of a structural VL model, and you have a black line and a blue pale line which are almost overlapping, so you don't see the black one, but the black one is the coverage of bootstrap, sorry, the coverage of confidence interval for the following impact when you say you don't screen. The blue pale line is that when, okay, I look for strong proxies, and then conditional of finding a strong proxy, I apply my approach. You can see that basically the two lines are overlapping. So we are not affecting second stage inference when we apply our bootstrap-based test. And I mean, that is because of the bootstrap. But if you do the same, imagine that this is the coverage in the presence of weak proxies, the red line, okay? If you screen based on the first stage F statistic, you see that you are going to worsen inference in considerable way. And the yellow line, on the other hand, is when you screen based on our test, you reduce the problem. So we have our bootstrap-based test is part of the procedure because we're not affecting the inference in our indirect identification strategy. I don't know if I get the point.
Okay, I don't know whether there are other questions from the audience. Let me wait. That's another question from Alessandro Casini.
Yeah.
Alessandro asks whether how does the strength of the proxy relates to time variation in the VAR parameters?
We are considering.
That's an example. Sorry, Luca, and then I'll let you answer the question. For example, could weak proxy simply arise from the variation in the fiscal multipliers? Because there's evidence of time variation in fiscal multipliers. He mentions the paper by Ramey and Zubairi, JP.
Yes, I also, you're right, Alessandro. In this setup, I am not taking into account possible, say, changes in the parameters. But let me mention also a paper by Daniel Lewis, a paper forthcoming on the RESTAD, where he exploits breaks, he exploits heteroskedasticity to infer. Let me show you this graph. You immediately see that there are at least I see at least two volatility regimes in this variable, especially total factor productivity. There is a paper by Daniel Lewis where he exploits heteroskedasticity to infer tax multipliers, and also the one you mentioned. But in my approach, I simply wanted to compare, say, our indirect strategy with the direct one under the assumption that, say, the VR parameter are constant over time. It is questionable assumption, I agree on that, but yeah, the next step would be revisiting our approach by admitting volatility breaks in the data.
Okay. So I don't think there are other questions from the audience. So let me thank you again on behalf of the CIDE. So Luca, thanks a lot for your presentation. Very nice.
I wish to thank the CIDE for giving this opportunity.
Okay, thanks again to you and to Francesco and Matteo Barigozzi, who organized on behalf of the CIDE the webinar series.